Hello. How you doing? Paul Fraley here. This is about the project, the Galactus project, for the Kepler 160e colony. That's about 3,000 light years from Earth, our star system. The Galactus program. Crew complements 250 people per ship. Now, this is going to be very expensive, each ship. In fact, I'm going to let you know right up front, Earth can't do this on its own. This has to be done through the Martian Space Agency, which hasn't been installed yet because we don't have a compound on Mars yet. But this is what it would take. And the ship would have to be in orbit around Jupiter. It would have to be built there, actually, at the Lagrange point, in orbit there. Okay, before I even get into this with you. Yeah. Okay, I got my notes here. The interstellar Kepler 456.04 star freighters are designed to explore and colonize Kepler 160e. There will only be 10 such spacecraft constructed. Are you kidding me? This is expensive. Each ship approximately 25 kilometers in diameter. Each interstellar ship priced at $5 trillion. Don't faint, please. I'm not done yet. The ships will be built and launched from the Jovian Lagrange point, one at a time. Capable of achieving 1/3 the speed of light for 2 years, it will accelerate to the coasts to the fourth world of the Kepler star system. That's Kepler 160e. Then the warp drive engines will kick in till it is 90% the way to its orbital destination. Basically, these star freighters are manned space stations designed to fly to the Kepler 160e destination. These ships carry 100th Earth gravities and will take only 100 years only. To cross the distance of 3,000 light years. Now, these plans are now only on the drawing board. Yeah. Well, it's because it's futuristic. It's going to depend on the technological infrastructure based on Mars, because you can't do it from Earth. You can't launch all these heavy parts from Earth. You got to launch pieces at a time from Mars. That's how it works. Now, I'll try to explain to you how we're going to survive with artificial gravity, because you can't go to another star system without gravity. Basically, it's just mass, atmospheric mass and tanks in the center of the vehicle, because you got to have a center of gravity there. That's where it's at. And behind it, you get your engines and your fuel tanks, because you got to have atmosphere to breathe, right? Yeah, that's how it works. Everybody in that ship will have to be in suspended animation. Also, after it coasts, it's going to have to engage its anti-gravity propulsion systems. A warp drive, based on some of the things I've read here in Paul A. LaViolette, PhD's book, Secrets of Anti-Gravity Propulsion. Sorry. Excuse me. I'll need to read a little bit back here, the blurb. In Secrets of Anti-Gravity Propulsion, physicist, and he's a physicist, Paul LaViolette reveals the secret history of anti-gravity experimentation from Nikola Tesla and T. Townsend Brown to the V-2 Advanced Technology Bomber. These technologies already exist. They're being used by the military. So, in case you're wondering what the heck we're talking about, that's what I'm getting at here. We already have it. Just like we've got transparent aluminum. And we've been working on UFO technology for a long time now. It's reverse engineered. So if you want to read about it, here, Tesla UFOs, classified aerospace technology. Well, here you go. This is the book. I don't know how that looks on your end, but secrets to anti-gravity propulsion. Yeah, he's the author. It is a thick book. How much does it cost? You know what? That's a good question. I imagine since it's so thick, and cramped packed full of information, this is going to set you back about 30 or 40 bucks, depending on whether you get it in Canada or the United States. So, yeah. That's how long it take to get there. Plus, it's a one-way trip. I want to tell you right now to Kepler 160E. It's a one-way trip. You ain't coming back. And we can only do it 10 times. This thing is expensive. It's going to take roughly 50 to 60 years to get all the ships launched. Maybe even 80 years. Who knows? Because it takes 100 years to get there. So how would we send people back and forth? Well, probably through a spaceship concept developed for a science fiction movie called Passengers. The ship was called the Avalon. And it had a very inexpensive method of creating artificial gravity, centrifugal force, which the Galactus ships do not use at all. They're built so once they all get there, they disassemble and come back together again as a space station around the planet. That's why they don't come back. And you got 250 people on each ship. So, yeah, a lot of robots, a lot of people, technicians, and stuff in cryogenic suspension. Risky as hell, but, if it can be done, well, that's fantastic. Well, once you get the other ships, the passenger ships going back and forth, let's see, it would be using this upgraded version of anti-gravity propulsion. You get there pretty quick, and probably within 20 years. You'd make it in 20 years. You get there in 20 years and spend maybe 10 years there, and come back and another 20 years, get back to Earth. That's what you're looking at here. That's my projection for this Galactus spacecraft program, going to colonize the Kepler 160E. It's actually called the Kepler 160A star system. A stands for the star. I already discussed it before in some of my other videos. Got to wrap it up. I want to keep it under 10 minutes. So this is the progress report on some of the work that's being done. It's on the drawing board for a star system 3,000 light years away from Earth. It's somewhere between Cygnus constellation and Lyra the Harp. So it's a long way off. It just goes to show you how far ahead we're thinking today. So that's it in a nutshell. This wraps it up. So I wish you happy holidays and happy New Year. And have a great life. And don't forget, keep looking up.